Hey everyone, welcome back. This is my third video on modulus functions and absolute values. In the previous video, we looked at what to do if your function was stuck inside some absolute value bars. But now, moving on, we're going to look at what to do if your function has absolute value bars inside the brackets. So let's take an example and see if we can work out what the general strategy is going to be. We're going to be drawing the graph of y equals 2 to the x as our base graph. So I'm going to create a quick table of values so that you know what this function is going to look like. If x is minus 2, the original graph would look like 2 to the minus 2, which would be 1 over 4. Because remember, 2 to the minus 2 is 1 over 2 squared, which is 1 over 4. Similarly, 2 to the minus 1 is 1 over 2, which is a half. 2 to the 0 is going to be 1. 2 to the 1 is going to be 2. And 2 to 2 is going to be 4. So the first thing I'm going to do is pencil in my asymptote because this graph never becomes negative in the sense that it never has a negative y coordinate. So my graph here is on minus 2 is a quarter, a half, it goes to 1, and then at 1 it's 2, 2 it's 4. So you can see it has this beautiful exponential shape. Now let's consider what happens if we take the absolute value of the x coordinate and then we substitute it into the function. So the difference between having the bars outside and having the bars inside means if they're inside like this, first we have to look at the x coordinate. We have to work out its absolute value, and then we take the absolute value of the x coordinate and substitute it into the function. So in my case here, if my x coordinate was minus 2, I have to take the absolute value of minus 2, which is 2. I'm going to have to take the absolute value of minus 1, which is 1. Now these x values here will remain unchanged, and that's because the absolute value of 2 is still 2, 1, etc. Now, if I take 2 and I plug it into the function here, 2 to the 2, 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0 is 1. 2 to the 1 again is 2, and 2 to the 2 is 4. And you might have noticed that there's a pattern emerging here. This is a reflection. And that is true of the graph also. So what you need to think about is where the points will go. Now here, at minus 1, the graph will go to the point 2, which makes sense because here, x equals to 1 and x equals to minus 1 now have the same y coordinate because for both of these, I substituted x equals to 1 into the equation. Now if we consider it for minus 2, I need to go to 4. Again, for 2, I went to 4, so for minus 2, I need to also go to 4. And my new function here looks like this. Now, the quick way, or my top tips for doing this would be, take your original function, draw a line on the y-axis, delete anything that was previously to this side. And what you can do then is take the part of your graph that's to the right of the x-axis, so in my case, and then reflect it over the line. Reflect it over the y-axis and you'll have the graph of f of the absolute value of x. Let's have a little look at example 1 on Geogebra. I've graphed the original function for you, the y equals 2 to the x function for you here. And then we can see that when we put the absolute value only on the x, this section here will be removed and will create a reflection of the right-hand side of the graph, using this as our line of reflection. So have a look here. You can see it looks exactly like that. The mirror line here is the y-axis. So that is the function of 2 to the power of absolute value of x. Now let's have a look at a quadratic function and what will happen to a quadratic function when we take the absolute value of its function. So to graph a quadratic function, I'm going to be looking at a couple of key points. I'm going to start by factorizing the function. And that's going to tell me where the y-intercepts are. So in my case, they're going to be at 4 and -2. So 4 here, -2. I can tell that my y-intercept here will be at when x is equal to 0. -2 times 0, which is -8. So y will be here at -8. So that one. And I also want to look at my minimum point. Now in this case, the minimum point here is going to be x minus 1 squared minus 1 minus 8. It's going to be at x equals to 1 and y equals to -9. So I'm going to take all of those points and I'm going to join them together. So this is my quadratic graph. Now what I'm going to do to draw the function y equals to absolute value of x squared minus 2 times absolute value minus absolute value of 8. Oh, that was a mouthful. I'm going to take this section of the graph, I'm going to remove it, and I'm going to reflect this proportion of the graph. Now this key point is going to help me also, and so is this one, to get everything just right. So I'm going to reflect the +4 here to be -4. I'm going to reflect this one here, which is now 1,9 to be -1,9. And I'm going to join up with my y-intercept. Remember, it has to be a perfect mirror line. And that's my new graph is going to look like this. Okay, and let's have a quick look at that on Geogebra. Let's look at our quadratic function. Here it is, it's got all the key points, the x-intercepts, the y-intercept, and the minimum point. And then we can look at what happens if we take the absolute value of the x. Yep. We can see it's got that perfect reflection where the graph has been, it's got that perfect line of reflection in the y-axis where the graph to the right of the y-axis has been reflected onto the left-hand side. What I'm going to do in the next video is look at how you can solve equations that involve absolute values. I hope you found this video super helpful. Please like and subscribe. That really helps the channel to grow. And stick around for the next video. We're going to be solving equations, making sure we get all the solutions when there is an absolute value inside the equation like this. See you next time, guys. Bye.